Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing about different types of system strats, and as part of that discussion we are now discussing on the transgressive system strat. In the last lecture we have seen that what are the overall nature of a transgressive system strat and its effect particularly on the fluvial onlapping system, the fluvial transgressive package that will form. So, we have discussed about that in our previous lecture. In continuation to that lecture, in the present lecture, we will try to understand what are the other areas where we can get the deposition during a transgressive phase, and accordingly we can get transgressive system strat developed in other parts of the basin. So, what are those possible other parts? So, we can get deposition in the backstepping foreshore areas where we can get formation of barrier beach or backstepping beach system, formation of backstepping bar systems. We can get deposition in the estuarine facies, particularly when there are smaller rivers, or in the river mouth area. In some cases we can get some deltas also may form during a transgression. So, these are the deposits, these are the areas which we commonly expect to have certain sediment package to form during transgression when we are concentrating into the coastal area. Now, from the coastal area, if we go further deeper, further seaward, there we can get deposition in the shelf area. Certain processes may go on in the shelf area, certain processes may go on in the deep basinal part, where also we can get some transgressive packages which may form under the transgressive phase. So, in this class we will try to discuss about all these aspects to get an overview of what are the major type of deposits that we can commonly get, that we can expect during a transgressive phase in a basin, particularly starting from the coastal area to shallow marine and then deep marine part. So, when we look into the coastline area, the transgressive coastlines, they are commonly defined in terms of the retrogradation of the open shoreline. So, when this kind of retrogradation is going on, open shoreline is retreating back, the river mouth could have a very complex character, a very complex manifestation, as it is controlled by sediment supply, which may have a completely different relation with the shoreline trajectory. So, based on that balance, based on that relationship of sediment supply by the river and the nature of the shoreline backstepping character, in some areas we can get a retrogradational pattern where we can get formation of an estuary, or we can get formation of an incomplete estuary with formation of some bayhead delta, or maybe a bayhead delta formed within an estuary, or in certain cases we can get a progradational condition where a delta may form even during the transgressive phase. So, estuaries are the most common manifestation, the most common feature that should develop at the river mouth environment, and it is considered as diagnostic for transgression, as these are commonly associated with the retrogradational shift of the facies, all the facies associations, and forming only during the landward shift of the shoreline. This also we have discussed earlier as well. But apart from these estuaries, there can be other type of environments which may form at the river mouth, as I told you, ranging from estuary to a proper delta through a phase of intermittent partially developed delta systems, commonly called as bayhead delta, which may be part of a larger scale TST, which may be part of or may form as a function of the balance between the rate of sedimentation and the rate of base level rise at the river mouth area. So, in this kind of scenario, we can get two end members. One end member, the estuary, other end member, the delta system. So, this prograding delta which commonly forms in case of larger rivers, where the rate of sedimentation outpaces the rate of base level rise, because in larger rivers the sediment supply is going on at much higher rate, amount of sediment coming in is at much higher rate, which is overpacing, which may overpace the rate of base level rise. Whereas on the other hand, we can have a normal condition, particularly we can observe this in relatively smaller rivers, particularly when it is an incised river valley. There we can see that when the base level is rising, that rate of rise commonly outpaces the sedimentation rate at the river mouth area, and definitely in those cases we get an estuary formed. And in between these two end members we can get some transitional conditions resulting in this bayhead delta formed in the river mouth area. So, we can think of the scenarios which are occurring in the river mouth area during a TST. During HST already we know, or during the normal regression already we know that in such condition the overall rate of sedimentation, is greater than the rate of base level rise, which is a case of normal regression. As we know, as we have already discussed earlier, during normal regression we get this condition to be satisfied, rate of sedimentation greater than the rate of base level rise. So, in such condition what happens, if this is the coastline, this is the strand line, shoreline, then a river may be coming over here, and this river will form a delta over here, and this delta will gradually prograde. Along with that, the strand line will also prograde in this direction. So, the entire system will be prograding, a prograding delta front, a prograding delta plane will be formed over there, a prograding mouth bar will be formed over there, which is a typical case we see in case of normal regression during LST or HST. But the scenario becomes complicated when within a TST, that means overall a transgression is going on. So, there we can get a different scenario with respect to this first one, the normal regression, because in this normal regression case, in the strand plane or in the shore area, it is a normal regression going on, whereas in the river mouth area, this area, there also a normal regression is going on. But during TST, we can have a different scenario. Say for example, if I take the same condition again where a river is coming in, but this river is a larger river. So, now we can have two different conditions that may develop in the river mouth area and in the shore area or along the shoreline. So, what kind of condition we can see in the river mouth area? In the river mouth area, the rate of sedimentation is overpacing the rate of base level rise. Rate of sedimentation is overpacing the rate of base level rise. So, in this case what is happening over here? The river will try to encroach into the sea, it will be supplying more sediments. So, the delta plane will be developing over here, delta front will be prograding, and finally the delta mouth bar will be prograding to this. So, we will get a formation of delta in this particular area. But if I am seeing over here, say for example in this area, or say for example over here in this part, what kind of scenario I can expect here? In this area, the river supply is less, the supply of sediment is less. So, in this shore area, the rate of sedimentation is actually less than the rate of base level rise. So, in this portion what we are getting, the accommodation is created more, and as a result the shoreline will try to transgress. So, in these portions we will get a transgression, whereas over here we will get a normal regression. So, a delta, just a common normal delta will form only along the river mouth area, rest of the shoreline will show a transgression. It will be a backstripping beach system that will be forming in the rest of the portion apart from the river area. So, what will be the nature of facies log if I want to make a facies model? Exactly in this part, exactly in the same kind of coarsening upward pattern that we can observe in a deltaic system. As we see over here in this kind of scenario, a coarsening upward pattern, exactly similar kind of coarsening upward pattern can be observed over here as well. Now, the scenario becomes different when the condition is changed. So, when we can think of a second condition where it is again a TST is going on, a transgressive condition is going on, and in this case the rate of sedimentation is still significantly high, but this rate of sedimentation is now relatively less with respect to the rate of base level rise, and this much of variation is occurring along the coast as well as along the river mouth in both the areas. But this much of changeover, this rate of base level rise with respect to rate of sedimentation, which is this rate of base level rise is overpacing the rate of sedimentation. So, that is not that significant that the entire river valley will be drowned, will be entirely flooded. So, in such condition what will happen? The river system will try to deposit the sediments over here, but that deposition of sediments will not be prograding that much, and the rest of the portions as if they will be going back. So, initially maybe the original shoreline was somewhere here and the river mouth has gradually opened up and it has retreated back, the shoreline has retreated back in this portion. By the time river system is also retreating back, but at any given point if I see or if I compare that with respect to the shoreline position, there will be a small delta forming over here. This kind of delta are commonly called as a bay head delta. So, in this situation what is happening? In the river mouth area it is a transgression going on, but a bay head delta is forming in the river mouth area, and in the other part of the shoreline what is happening over there? It is simply a transgressive beach, it is a retrograding beach is forming over there. And in this case the amount of transgression, it is more than the drowning of the river, drowning of the river mouth. So, that is responsible, that particular factor is responsible for the formation of bay head delta, which is a kind of transitional phase between the two end members, a pure delta and a pure estuary. So, this kind of condition can be considered as an incomplete estuary, and very commonly we get this kind of estuary to form in unincised river valleys, where the sediment supply is quite high and it is to some extent kind of balancing this effect of retrogradational pattern. So, in the river mouth area, in the coastal area, we can get this kind of retreating shoreline associated with a less developed delta form, commonly we call them as a bay head delta, which may be a part of an estuary or that may be a part of the river mouth associated with the shoreline condition. A variation of this, the third kind of variation is where the rate of sedimentation is significantly outpaced by the rate of base level change, base level rise. So, definitely there will be overall transgression, and that transgression can be observed both in the river mouth area as well as within the shoreline in both the areas. So, in this kind of condition what we expect? The formation of a proper estuary that will form over here, and at the river mouth area over here we can see formation of a Bayhead delta. So, in this kind of scenario where we are getting a proper estuary, we have to satisfy this particular condition that the rate of sedimentation is significantly overpaced by the rate of change in base level. So, in this case the shoreline is retreating back, the entire mouth burst system which is forming over here, they are also retreating back, the Bayhead delta system is retreating back, the entire estuary is retreating back. So, in this kind of condition again we are getting a Bayhead delta formed over here in this area, and this is a well developed estuary. So, this kind of estuary are commonly expected when the river valley itself is a small river. So, the rate of sedimentation, amount of sediments coming in are less in amount, so that the rate of rise can overpass it. So, this kind of estuary formation are commonly associated with smaller river systems. And also very commonly we get formation of this kind of estuary in incised channels, those channels which were incised during the base level fall. So, those incised channels gets drowned very quickly during this phase. So, in this kind of scenario the drowning effect, the drowning of the river valley is greater than amount of transgression. That is why the river valley is getting flooded and forming a complete estuary. So, in the coastal area during transgression, the shoreline and river mouth can have a completely different type of architecture, a completely different type of manifestations in terms of the depositional conditions, in terms of the depositional systems. So, between a proper prograding delta and a fully developed estuary, we can also get a retrograding Bayhead delta system, which may also develop where estuaries are partly drowned by the rapid transgression of the adjacent open shorelines. We cannot get this kind of Bayhead delta to form in any other scenario, in any other condition, in any other phase of base level change. The complete estuaries, they tend to form at the mouth of incised valleys, which commonly facilitate the drowning of the rivers at the rates that are higher with respect to the rate of transgression of the adjacent open shorelines. So, in the coastal area we get variations in the facies models, variations in the facies architecture depending on what type of coastline, what type of mouth burst system, river mouth condition is finally developing, and that will control the nature of facies architecture formed in that part within the coastal area during a transgressive phase. Now, as this process is going on in the coastal area, mostly the sediments which are derived by the river system, they are trapped, they are carried and deposited within the fluvial system as the fluvial system is aggregating and showing onlap, and also they are getting trapped within this estuarine deltaic kind of condition, open shoreline condition. So, effectively due to this trapping there are two manifestations. One, we get a transgressive prism formed comprising the fluvial to coastal area, maybe to some extent the very marginal to shore environment that can come, that can also be a part of that. So, we get a transgressive prism as we have seen in case of a low stand prism, in case of high stand prism, similarly a transgressive prism will develop. And the sediments, the dominant terrigenous supply is trapped within this transgressive prism. So, it is getting trapped within the shore environment, starting from fluvial to coastal, where within the coastal we are getting estuaries, deltas of different types, and the open shoreline including the barrier beach system. So, there the major terrigenous sediments are getting trapped. So, the additional sand which is incorporated within the shelf area, which may get supplied into the shelf area, they are commonly generated by the storm surges and by the tidal currents. So, wave activities, particularly the fair weather wave activities, they are mostly confined within this transgressive prism, within this shore face area or into the shore area. Beyond the shore area, as we go down to the self area, there we can expect within the transgressive package very less supply of terrigenous material, but in certain cases we can get some major structures, commonly we call them as the macroforms. For example, some very large sit-like features, sit-like deposits, very large ridge-like deposits, ribbon-like deposits commonly formed by sand or coarser grain sediments. So, the agents which are responsible for bringing, for carrying and depositing these sediments are commonly the storm surges and the tidal currents. So, the shallow marine deposits may include, as we have discussed so far, up to the coastal area. Now, looking into the shallow marine part, which includes the outer part of the shore face and the entire self area. So, that shallow marine deposits, that commonly includes the transgressive lag deposits. They also includes the self sand macroforms, where we can get sit like or ridge like geometry, and we get condensed sections. So, what are the implications of individual these types of deposits? So, a transgressive lag, as the name suggests, it is the lag deposit. So, where we get this kind of lag deposits? During the sediment transport, the coarsest clasts which are produced by wave scouring or maybe available, maybe supplied by the river system, maybe otherwise available within the shore face environment, they are commonly left behind as a transgressive lag on top of the wave ravinement surfaces. So, wave ravinement surfaces which are forming by this wave scouring, wave reworking in the shore face area, on that surface we get this kind of lag deposit which are called as transgressive lag. So, these are nothing but the coarsest materials available in that particular setting, and they are not carried forward by the available energy system of the agent or the mechanism which is going on in that particular depositional regime. The finer sediments, which commonly includes most of the sand size fraction of the clasts, apart from that the transgressive lag deposits, these are transported, these relatively finer sediments, sand size grains, they are transported further onto the self, and in the self area they can form sit like or ridge like self sand deposits. What are these deposits? Self sand seats. This is a very common term used for self deposits. These are known to form relatively thin, around 1 to 3 meter in terms of their thicknesses, and potentially very much laterally continuous over several hundred square kilometers. So, they just get deposited, they just occur like a blanket over the entire self area for a very large area, where we get commonly an upward fining sandy deposit. These are called as self sand seats, commonly carried by the storms. The self storms, they commonly bring this kind of sand and they gets deposited. Self ridges, another macroform that we commonly get in the self area, are also sand rich, and they are usually more thicker with respect to the sand seat deposits. So, commonly the ridges are 5 to 10 meter thick, and they are again regionally extensive, commonly form upward fining succession of well sorted, cross bedded to bioturbated, fine to coarse grained sediments, commonly sand. So, this kind of deposits are commonly found in the self area. However, the major sediments are getting trapped into the marginal marine part or in the coastal part or in the fluvial part. So, these macroforms, they commonly overlie the transgressive wave ravinement surface which have abandoned the self area, which have abandoned the entire self area following the retreat of the shoreline. And this abandoned shoreline, as the shoreline has retreated to the landward direction, this entire self is lying completely open for deposition, and they tend to get deposited by storm activities or tidal activities. So, commonly they get oriented parallel to the axis of major structural embayments which may be present in that particular area, and that commonly channelizes the energy of the tidal currents, and as a result of that these major deposits get aligned along these particular linear zones. So, both the sheet-like and the ridge-like self sand deposits may form excellent regional reservoirs as they get encased or covered up by the self fine grained deposits, fine grained sediments, commonly the hemipelagic or pelagic sediments which are characteristic of self deposits, and they act as good seal material for these reservoirs. Now, coming to the self edge area, overall the self edge area is relatively stable, or it is affected by some occasional storms as the entire self is exposed for storm activities. So, during the late phase of the TST, in the areas which are closer to the self edge, commonly we expect the supply of sediments to be very low except local or intermittent storm activities. So, when there is no storm activities, commonly we expect an overall sediment starvation, lack of sedimentation, because these sand deposits, sand macroforms, they are localized deposits. Apart from those sand macroforms, the rest of the self area up to the self edge, they are commonly not getting sediments during this transgressive phase, particularly when it is the late phase of the transgression where the water level is significantly high. So, what we expect over there? Formation of condensed sections. As we have already discussed about condensed sections in our previous lectures. So, condensed sections are nothing but the deposition of hemipelagic or pelagic mud under a very low energy condition. So, their rate of sedimentation is very slow. So, within a large time gap, large time interval, we get relatively thinner deposits formed which represents the condensed sections. Now, if we look into the deep water part of the transgressive systems tract, there we can get deposition in form of submarine fan, and these submarine fans, they can form in successive stages. So, we can get some low density turbidity currents which may form at the time of early transgression, or we can get some high density mud flow, high density debris flow which may form during the late transgressive phase. So, during transgression again we can get variation in terms of the depositional conditions and processes and the resultant products in the depositional part. Initially it is an low density turbidity currents like the LST phase, and at the late phase of transgression we commonly get high density debris flow or mud flow deposits like the early phase of forced regression. So, these are commonly associated with localized sediment sources and channelized sediment transport. The low density turbidity flows, as we have seen in the case of LST also, and in this TST case, for example, during the early phase of TST, early phase of transgression, these low density turbidity flows, they travel far from the self edge into the basin, because there the proportion of mud in the system is much higher, which helps in sustaining the flow and construction of levees along the channel banks over large distances. So, as the flow is coming down the slope and getting spreaded over the basin floor, it is not getting much chance to spread over across the bank, spilling over the bank because of this levee system. So, they flow for large distances and finally they get deposited. So, during the late phase of TST, majority of the riverborne sediments are commonly trapped in the fluvial or in the salomarine transgressive prism, and that can include the fluvial, estuarine, deltaic open shoreline as well as the shore face sediments and to some extent the self sand deposits. So, as a result, the deep basinal part is not getting much sediment supply. So, when the base level is rising, it results in hydraulic instability at the shelf edge, and that can cause erosion of the outer shelf or the upper slope areas where dominantly fine grained sediments are getting deposited. Mostly the condensed sections are forming by deposition of pelagic or hemipelagic sediments. So, when that area is getting disturbed hydraulically, they are getting unstable, and from there successive debris flow are developing moving down the slope. So, the source material is dominantly mud. So, the resultant flows are also mud flows. So, successive mud flows are generated during the late phase of transgression. So, how this kind of deposits are formed and how we get successive preservation of this kind of deposits, what are the conditions, that we will discuss in more detail with the help of some simple diagrams to understand the dominant processes which are occurring from early phase to the late phase of transgression within a basin and what are the resultant products. So, this we will discuss in more detail. So, this lecture, this discussion will continue and we will continue this in our next lecture. These are some of the references that you can go through for further reading on this particular topic. So, thank you everybody.